Good morning, everybody. Thank you all for coming out. We are here to talk about what's new in networking. These are the SIG network chairs. Well, we got Dan here. Casey's somewhere in the audience. There's Casey. And we've got Bowei and the other Dan, who are some of our top contributors in SIG network. So we're here to sort of tag team on you today. So we only have 25 minutes, so we're going to kind of burn through this. If you have questions, please raise your hands and jump up and scream, or we can talk afterwards. First, I want to talk about a few of the things that we got done in 2018. So since last year when we were here, we have merged a whole bunch of changes in no particular order. We've got traffic shaping in our CNI network spec now. So the traffic shaping, which is sort of this thing bolted onto pods, is now actually a first-class thing. We have support for network policy egress and CIDR rules. That went to GA in Kubernetes 1.12. We have the IPVS version of kube proxy. Hallelujah. It scales much better than the IP tables version. So for those of you who are running these massive 8,000 node clusters, you can actually do this now. I know there's a lot of you out there. We've also merged core DNS as a default replacement for kube DNS. So for all of you who've had some DNS pain, hopefully it's a little bit better. We've got some more on that later and on how life is getting even better in DNS space. And then we have a cool feature that lets you figure out which IP addresses you want to expose your node ports on. These are just a few of the things that popped up through the release notes through the last year. I'm sure there's more, but I apologize if I missed those. A bunch of things are also in flight. This is where the exciting stuff is. We have IPv6 support in Kubernetes. I don't know if you knew that, but it's alpha in Kubernetes since 1.9. The team that's been working on this has been working on continuous integration development and has been working on the follow-on to this, which is dual stack v4 and v6 at the same time. We also have custom pod DNS policy. So for those of you who don't like the default DNS in Kubernetes, from your pod point of view, you can change all the settings that you have for your pods in flight. That API is beta since 1.10. I don't see anything that would stop that from going to GA. We also have a really cool feature coming up. As of 1.11, it was beta. It's called pod readiness gates. What this lets you do is have dynamically adjustable readiness for your pods. So if you have a load balancer that needs to sync with your pods, you can actually have it out of tree feed back into the readiness loop of pods so that your rolling updates of your deployments or whatnot can wait for your load balancers to catch up. This is very excellent for external infrastructure. We also added support for SCTP, that other IP protocol. Apparently, people still use it. It's actually not that uncommon. I'm surprised. So we've got support for it. It's alpha in 1.12. I don't see anything that would stop that from going to GA. And as of 1.13, which was 5 minutes ago, we've got support for node local DNS caching, which should help a whole lot in people who are having DNS problems on UDP lossy networks. So this is a huge deal. This sort of catches you up. Again, there's a ton more going on. These are just a few of the things that are in flight right now. And then coming up, we've got a whole bunch of things that are also sort of at the beginnings of being in flight, and these guys are going to talk about each of these things in detail. We're working on Ingress. We spent a lot of time at KubeCon last year talking about Ingress. We've got an update on where we are with that. We've got dual stack support, which is v4 and v6 at the same time, multiple IPs per pod. Node local services, this is something people have been asking for a long time. How do I talk to the copy of the daemon that's running on my machine? We're talking about possibly a revamp of services and endpoints. Anybody who was paying attention to Brian's talk saw him start to allude to some of the pain points around there. We've got some work around Multicast. A lot of people want to use Multicast in Kubernetes, so we've got some updates on that. And Windows. Windows support is a thing, and we've got a little bit of an update on Windows networking.
Okay, so I'll talk about Ingress. So Ingress is currently lowest common denominator API, and our thoughts is to sort of change that and change the strategy by which we express L7. It's very clear from the survey earlier this year, I think, oh gosh, it's January, that users are not happy with it. It's too many annotations. Most are not portable. I think we found in the survey about 60% of users use annotations, and probably more. And in 2018, we expect more from an L7 proxy, right, than just prefix matching, for instance. So this was a hot topic at KubeCon 2017. There was a lot of conflicting input. from the survey. It's still not resolved, but we have a couple ideas, so please catch us in in-person conversation. I think this is a great place to sort of get all those ideas out and kind of understand where the community sits in this. Next slide.
So IPv6 and dual stack. So like I said, we have single stack v6 now, which means you can bring up a Kubernetes cluster in pure v6 mode or pure v4 mode, but not both. There's a KEP, a big KEP. It's very detailed. It's approximately done for the dual stack support. It requires some really significant API changes, actually, which required us to argue a lot within SIG architecture about how do you actually evolve bits of our API in compatible ways. For example, how do you take a single IP address and make it a list of IP addresses in a way that is rollback safe forwards and backwards? It's actually a fairly complicated topic. I was a little bit surprised at the depth of it. Also adding multiple IPs for endpoints and how do you disambiguate whether you're speaking through v6 or v4. It also requires kubeproxy, which is always run in one of these modes, to now run in both of these modes, which is going to be an interesting bit of code to write. For kubelet to handle host ports in multiple IP families. We're not adding IP family conversion, so you can't come in as v4 and get converted to v6, but we will allow you to come in through either protocol. Honestly, this is a huge effort. It's gotten a lot bigger than I thought it would. This is a place where I'm calling for help. Anybody who's in our community who wants to help develop and test this, or even just feedback on the ideas, read the KEP, we could totally use your help on this one. I'm doing topology. So the other topic that I think is really exciting right now is node local services. This was actually a proposal several months back by a community member. It was fantastic. They proposed a very simple API for this, and I said, hold on, I think it's bigger than that. And we spent a whole bunch of time exploring how big it could get, and we came back to the simplest solution is actually the best, which is awesome. The KEP is in progress now. I think actually it just got merged last week, which means the development is going to happen. It, like so many things in Kubernetes, is surprisingly complicated. So even though it's one field in the API, it's actually fairly complicated. We're going to need a new resource type to describe some of the forwards and backwards lookups. So we're going to start with a sort of limited alpha. It won't have all the functionality, but it will let you finally say, I would like to talk to the logging agent or the monitoring agent on the same machine as me, which is a pretty huge deal, I think.
Okay, and as Brian alluded to earlier, it looks like it's time to revisit how services and endpoints are designed. At least concretely, we know that the endpoints, kind of the way it's structured today, results in an n-squared scaling factor, which doesn't work if you have, say, thousands of service endpoints. And in the other piece that's relevant is that services themselves are kind of this mashup of all the various features. And you could imagine the resource being more orthogonal in its design. So we have some nascent ideas, but nothing really concrete at the moment. But we're going to look into sort of rethinking and refactoring this whole set of services to kind of get it more orthogonal and more scalable.
So this is a place where if people are doing network development, if you're doing things with meshes and other areas, I would love to hear feedback on the problems that you're having with services and endpoints.
So I just submitted a KEP for Multicast. Some people, especially like JBoss, for instance, if you have a high availability group, the servers use Multicast to find each other. And so people are doing things in Kubernetes that want Multicast support. We don't actually specify what happens at all when they try to do that. Most plugins don't support it. We're trying to find a good way of configuring it in a way that, not everybody will be able to support it because like some of the clouds use an underlying network that have no multicast, but we're just sort of trying to figure out what to do. The KEP actually got closed when they all got migrated, and I have to reopen it.
So if you have thoughts on multicast, please come talk to Dan. We didn't introduce ourselves. Do you guys want to real quickly introduce yourselves?
I'm Dan Winship. I work for Red Hat on networking stuff.
I'm Dan Williams. I work for Red Hat on networking stuff, too.
I'm Bowei. I also work on networking stuff. Surprise, from Google.
All right, Windows support. It turns out that people actually want to run Windows-only clusters and mixed Windows and Linux clusters. So over the last year, there's been a lot of work from Microsoft, Cloudbase, and a couple other places that have added Windows support at a bunch of layers in the Kubernetes stack. Kubelet, kubeproxy, the network plugin, and CNI layers. The overall support's currently at beta, but there's a little confusion around what levels of support there are for different Windows versions. The earlier support didn't quite work like all of us expected it would because we just weren't familiar with how Windows dealt with containers. But it seems like that's converging a little bit more as different Windows versions come out and different updates are happening for Windows side. So I think that will become a little bit more streamlined and a little bit more like the Linux side of things. There are some differences. For example, with DNS, there are some peculiarities with how Windows needs the DNS to happen because guess what? Its networking just doesn't look like or work like Linux does. And some things aren't possible that Linux has supported for a while. So that's continuing to be work done, and we expect a little bit more convergence in how Cube runs across across different OSs. So if you want to contribute there, that's also a good place to help out and because the PRs are very large, or at least they have been in the past, and it's hard for those of us that don't work on Windows daily to actually review those PRs in a sane way. So if anybody has comments, talk to us or jump on PR reviews on GitHub as well, please.
So there's also a bunch of efforts that are going on that are happening outside of the core of Kubernetes, which I think is fantastic. Specifically, we want to talk a little bit about multi-network support, network service mesh, and other service mesh integrations.
All right, multi-network. This is something that's come up from a lot of different use cases, and some of those are not traditional cloud-native use cases. And it had been kind of percolating for a year. We had some various kind of false starts, I guess, or POCs and research maybe about 2 years ago. Last year at KubeCon in December, we kind of formed a working group to kind of work through these issues, a place where we could talk about them and not necessarily conflict with or put these discussions into SIG network, so that we kind of just have a more focused working group. What came out of that was over the last year we developed a specification for tackling some of the problems that people in that space in the network function virtualization or media function virtualization use cases had. And we wanted to keep the solution simple. We did not want to change Cube API. We wanted to try to put some of these things, keep them outside of Cube and just prove out those use cases without making too many changes to Kubernetes. So there was a specification developed over the last year about how pods can use multiple network attachments. Essentially, you get multiple IPs or multiple kernel interfaces in your pod, and your pod exists on multiple data planes. There are some interesting intersections with resource management. For example, if some of these network interfaces are a finite resource on the machine like SRIOV, how do we handle that? So we're working with the resource management working group to figure out how we account for those resources and how we make sure that things like that and IP addresses and other things don't get over committed on each node. There's a spec. There's for that on GitHub, mostly built around CNI, but doesn't necessarily need CNI. And we've got a talk later in the week at KubeCon about it in more detail. And also, so the previous multi-network working group was a little bit more focused on like the year, 2 years, just to try to get something going. And network service mesh is kind of a slightly longer term looking project that also tries to tackle that problem and a couple other problems in the networking space, but in a way that is perhaps a little bit more cloud native, a little bit more mesh-like. You can kind of think Istio in some ways for networking. In terms of how you set up pods to talk to other things. Instead of saying, I want this other data plane for my pod or this other network for my pod, it's more abstracted in terms of, I want to talk to this service and here's a little bit about my requirements for talking to that service. And when we say service, we don't necessarily mean a Kubernetes service, but something in the cluster that requires networking. And Network Service Mesh is really a project about how you get your pods to talk to that other thing. And there's a lot of underlying infrastructure there. And they're currently working through that. It's looking interesting and pretty promising. I think it still has a little bit to go. But that's certainly another approach to the problem that people are really interested in and is starting to be Yeah. Anyway.
And just to say again, all of these, the current topics, are being developed out of tree. So these are using custom resources and extension APIs to extend and build out the Kubernetes API server, which was one of the topics that Brian talked about earlier this morning. And I just want to call out as a really sort of awesome point that these teams can do this work without having to be subjected to the rules of Kubernetes and the pace of the overall project.
Yeah, and one last thing on that. I mean, there's so many things that people want from networking that it's very hard to try to put any of this into concrete Kube API. And so one of the things that Tim really emphasized and others emphasized at the start was, make sure that you know what you're doing and do it outside of the API using things like third-party resources, which are now custom resource definitions. Make sure you know what you're doing first, and then maybe we can talk about kind of solidifying some of that stuff. But I think at this point we may not even need to do that.
So to follow on, not just at L3, L4, we find that people are looking to service mesh to solve a lot of their problems. And at the same time, we see that, for example, if you layer Istio or a service mesh on top of Kubernetes concepts, some of them are fairly overlapping. You can think network policy, definition of service, and so forth. So we're trying to look into how to make these things mesh more cleanly, at least define kind of, or resolve some of these overlaps. It seems like we can make it fit better and easier, at least from the design. Next.
So to get towards the end here, we've got a couple of speculative, looking forward things that we're talking about. Maybe building more into Kubernetes. Multi-cluster is a topic that has come up over and over and over again. We've gotten away for the last 4+ years saying that Kubernetes is a cluster abstraction. Well, it turns out that in the real world, people have multiple clusters and they want to be able to work across them. So we're very much at the beginning of what Kubernetes proper is going to take here. But I think we can no longer ignore the reality that multi-cluster is a thing that we need to deal with. And similarly, an idea that floated by fairly recently was cloud-native functions, sort of virtualized network functions for containers. Container network functions, CNFs. I don't really know what we're going to do here. There's a whole industry built around networking that is assuming the ability to hook into various service chains. And so I think we owe it to that industry to figure out how Kubernetes can play in that space better. Looking forward, we have a couple of options, things that have been proposed but not really made any traction yet. I talked about these same points in Copenhagen. Network plugins via gRPC. Let's talk about these.
Yep. So currently the network plugin API for Kubernetes is based on CNI, which is a process and exec model. So one of the things we're looking at is how do we transform that into being a gRPC-based model, because most of the other plugins in Kubernetes use gRPC. Why should the network plugin model be different? And so there's opportunities for tighter integration there, perhaps better reliability as well. So that's definitely going to come up in the next year or so.
One other thing we're looking at is how to sort of make the DNS schema better. So there's a couple of issues right now. For example, you can alias it, names, if you use the correct namespace and name. And how do we do a migration while we preserve compatibility? So definitely the DNS spec needs a re-examination. Also, in terms of DNS, we need to look at how this intersects with policy. For instance, should all names of all services be available to everyone, which is the case today? How can we kind of downscope it so that names are only available to the right set of consuming pods?
And so truthfully, there's probably 100 other things that are in flight that we haven't talked about here. I apologize to people if I missed your favorite topic. The reality is SIG Network is a fairly big SIG. We get a lot of people who attend our calls every couple of weeks. But we have a relatively limited contributor base. So the call to action here today is if networking is something that's interesting to you or your company or your teams, we could sure use help. We have a lot of code that needs better tests. We have a lot of refactoring that can be done. We have a lot of catch-up work around things like component configs and component isolation. We could totally use help in SIG Network. Otherwise, we will continue to chew away at it for the course of the year, and I hope that we have more stuff to talk about next year, but I also hope that your pet projects would be on here.
You have a minute for questions.
We have questions. Do we have no questions today? I don't buy it.
I have a question about multicast, actually. You've been saying that it's something that depends on the actual implementation of the provider. I just wanted to know if there's maybe any plans to like try to support multicast on an higher level instead for those that doesn't provide that. I know it's difficult.
So Kubernetes, Kubernetes core only has limited control over networking functionality. It's all delegated to the network plugins. So the idea that we're looking at is we will provide a way for an application to say, I need multicast to work here, and then the network plugin deals with actually implementing that. And so some of them, like Weave currently implements multicast. It's one of the few that does, and it will implement it even if you're on top of a network that doesn't implement multicast underneath. Yeah.
We're done. We're out of time. If anybody has more questions, you can meet up with us afterwards.
They also, you have a birds of a feather at 1, too.
Yes, we have a birds of a feather, so please come and beat us up about networking. Thank you.